the instrument to measure pressure. So let's say that we have a U-tube and we have here oil and we have here water. Because the oil is less dense than the water, it will push to a certain level. So this will be below that level. Let's say for instance that I give this distance, which I will call the height of oil. This is the working principle of the barometer. You know, sometimes you heard another unit for pressure, which is the height in the column of mercury. How much is the atmospheric pressure using the height in the column of mercury? Have you heard that unit? 760, right, millimeter in the column of Ag. So sometimes you will put it, the atmospheric pressure at 760 millimeter in the column of Ag, right? This is the way you put the atmospheric pressure. That's another unit you're using very frequently in chemistry. So this is this column. So what will be, assuming that you have that this column is the column of water, H2O. For instance, let's say H of oil is 5 centimeter. H of water, 2 centimeter. The question, find the density of oil. Knowing that, we want to find the density of oil. So, knowing the working principle of the barometer, so the Pascal principle said that at one point, the pressure has to be the same pressure than another point if the liquid is the same. Because this point is water and this point is water, they have here the U-tube. At this point, the pressure has to be the same than pressure at B, which is the weight of this fluid over this area has to be the same than the weight of this fluid over this area. Everybody got that? The weight of this fluid over this area, assuming that it's the same area, will be the same than the weight of this fluid over this area. So, knowing that, we can say that the density, I mean the absolute pressure at A has to be equal to the absolute pressure at B. Applying the Pascal principle, we know that the absolute pressure will be the external pressure, which is the atmospheric, plus rho of oil, G, H of oil, equal to what? What will be equal to? The external pressure acting on water, which is the same, atmosphere, plus rho of what? G, H of H2O. What will happen to PO? So can I find the density of oil? So what will be? Rho of water, H of water, divided by H of oil. And this is just basically the working principle of the barometer, which is the same than this application of Pascal principle. Any question? The U-tube example. Another example where we will use the Pascal principle will be the hydraulic lift. What is a hydraulic lift? You call the jack that you use to lift your car when you have a flat tire. Those days when you have a test and you say, oh, I have a flat tire, right? We use the jack. That jack is the hydraulic lift. So in a hydraulic lift, we use, the principle is the following. you use a very small area where you can put force, which I will call force in, and this cross-sectional area will be the area in. And then, in another place, we use a greater area to lift a car. Here I put a platform, and I will put a car here. You want to lift the car. So the question is, how much force? So the force going out when you push here in the hydraulic lift, when you start like an inputting force, what will happen in the other side? It will lift the car. Right? Yes. So this is the force in, this is the area in. This is the force out. Let's say that the force out is 4 times the area in. My question is, what will be the force out? So let's say that this is 10,000 kilograms times 9.8. So 10,000 newton, not kilogram. 10,000 newton, let's say, a light car. 10,000 newton. My question is, what will be the force that you need to input to lift the car? How much? 4 times this. So if the pressure here and here is the same, the force that you have to do was how much? 4,400? I said 2,500. So 2,500. That's right. Why? Because this area is how many times? 4 times bigger. So applying that this, the pressure here and the pressure here are the same, so I can say that the pressure in is equal to the pressure out. Since this is not open to the atmosphere, the only pressure here is the pressure that I have at this point and at this point, having the same fluid in both sides. What will be the pressure in terms of force? What is pressure in terms of force? What will be the pressure in terms of F? F over the area. So F in over force out is equal to the area, my bad, over area in is equal to force out over area out. I am looking for the force that I need to input. So will be the force out over the ratio of the area. Area in over area out. So the force in will be, how much is the force out? 10,000 times H in over, how many times is the area out? How many times? Bigger than the area in. 4 times. So will be 4 A in. What will happen to A in? Cancels out. So how much will be the force? 2,500. Will be 2,500 Newton. This is another example where we applied the Pascal principle. Any question with the topic hydrostatics when the fluid is at rest? Basically, that the pressure at any point, absolute, is the addition of the external pressure plus rho GH, which is the depth. Second, that the pressure at one point will be equal to a pressure at another point, and those two examples. This is called mechanical advantage. How much is the mechanical advantage? This is called mechanical advantage of the system, of the hydraulic lift. How much is the mechanical advantage in this case? 4 times. So 4 is the mechanical advantage of this system. All right.